Managing Director for McHanman Engineering Company, located at Kwashima. And then Mr. Emmanuel Tete is the Production Manager of Gratis, located at Tema. So, Mr. McHanman, Dr. McHanman, please, let's see you. All right, and then Mr. Tete, please, let's see you. Let's give them a round of applause. Good. Once again, we have our IEA experts here. That is Cynthia, Dr. Cynthia. But in IEA, everybody is Mr. and Miss. All right. To harmonize the effort they are trying to put across. So, Dr. Cynthia and then Dr. Joseph. Shall we give them a round of applause? You are all welcome here today. Thank you. Moderator, your audience. Audience, your moderator.
Thank you. Oh, okay. Hello. Thank you, Dr. Nete. Are we starting? Okay, so, as it has been put before us by Dr. Engineer Nete, today's main topic is enhancing Ghana's cassava cultivating and processing industry through machine design and fabrication by Dr. Ebenezer K. Hammond. And I think without much ado, we'll allow Dr. Hammer to take us. Dr. Hammer?
Thank you, and good morning to you all. I think for the purpose of this presentation, I will say I am also the president of EDFAC, which is Equipment Designers and Fabricators Association of Ghana. So I prefer to rather, do that in that capacity. Thank you very much. I want us to know the importance of local fabricators or equipment manufacturers when it comes to cassava processing in Ghana, and some of the challenges.
So, hello. As Doc continues, I'll just point out, hello Doc, that we have 10 to 15 minutes for the presentation.
So, and also to let us know the importance of local fabricators and some equipment that local fabricators has manufactured so far, and some challenges on the equipment and the processes using the equipment. I think for the purpose of time, I will skip this because I don't have to give introduction and discussion. I will go straight to some of the products that we get from cassava, the finished product. We have in Ghana, we process cassava into gari, into high quality cassava flour, cassava chips, starch, ethanol, aguelima, which we use for banku, cassava powder or konkonte and tapioca. To be able to manufacture an equipment, you should know the product that you are doing first. Local fabricators, in fabrication, first, you should know the type of material to use, whether it is food grade. 2, the effect of the material on the finished product. 3, as a fabricator, you should also consider that what you are doing will be user-friendly as a machine, cleaning and others. As I'll go along, I will explain that. In cassava processing, we have general equipment which we use, which cut across all processes in cassava. All the cassava processing, this thing uses this general equipment, and I call them general equipment. Before you can process cassava into any form, you may need those equipment. That's why I call them general equipment. The general equipment are tumbling cleaner. Before you use cassava, there is a first skin which is dirty. So you use a cleaner to clean it. I call it tumbling cleaner. That is the one in your shot. And that one will take first skin. We also have a pillar. The pillar has been a problem worldwide. Though there is a mechanical pillar, but when you are using it for starch, it's good. It becomes a problem. Because if you truly want to peel cassava to get it correctly peeled or rightly peeled, you may lose almost 30%, in some cases to 40% of the food. So it's been a problem worldwide, and it is not only in Ghana. So most people prefer peeling locally by using knife. But we have designed a special peeling station that we call peeling conveyor. What we normally do is that it's a long conveyor with tables on the side. So when you peel, you put the peels right down and it goes into a waste bin, whilst the food itself goes into a washer. So in your short is a washer for cassava, and the washer washes the cassava. This is a mechanical peeler, and that is what I just said. It sometimes gives waste a lot of food. When you are processing something into gari, you have to get a grater. Grater, we all know. Grater and rasper, they grate or they chip cassava into smaller pieces for frying. This is a cassava press. It is also for gari. This is used in squeezing the milk or the cassava water out. We call it cassava milk out of the cassava. Then you get only the pulp, which we later dry and fry. In your short, it's a mechanical fryer. Again, there's a problem with this machine. Most people using mechanical fryers are not getting the taste. So there again, there's a problem on a mechanical fryer. And I'm not saying this. We've asked a lot of people who are using it. So I am appealing to fabricators. I don't know whether there are some fabricators here, but if there is, I am appealing to local fabricators, because cassava is one of our main staple food or crop. So we should try and find a way of trying to better it. I know when we put our heads together, there is a way that we can do it better. This is also for gari packaging. It is a foam, fill, and seal. Let me just say this. Maybe I am just marketing myself. All the equipment that I've shown were manufactured by Macam Engineering, which I happen to be the CEO. So in your short, it's a combination of cassava washer, a chipper, and a conveyor. The chipper, if you want to do a cassava powder, you first have to chip it and dry. So you need a chipper to do the chipping. And this is a long chain dryer. Again, this long chain dryer, most fabricators can't do it well. We have a cabin dryer, open bin dryer, or long chain dryer. In a short, is a long chain dryer. Once again, I am appealing to, we went to a place and they've used my steel chain to do a long chain dryer, and within 2 months, it started rusting. Please, let's use the right food grade materials for our work. This is a cassava milling machine. After drying, if you want to pulverize or mill into smaller particles, you use what you call a pulverizer or a milling machine. This is our design. It has 3 drums, and all of them mill at the same time and goes into a different bin under it. This is also our design, Macam Engineering. This is a sifter. After milling, or even after you've fried your gari, you have to sift it. Sifting is separating or sieving. It's a segregator. It means you are separating the smaller particles from the bigger ones. And this is some of them. This is a sifter for purposely for gari. And we have what we call auxiliary equipment. This auxiliary equipment can be an equipment that is aiding the production processes. In the short, is a conveyor, which is a belt conveyor that can transfer a cassava from right from the loading bay into the tumbling cleaner for cleaning. Because of the challenges that we've had so far, complaints from processors, that's why we decided to form an association called EDFAC. It is to streamline, help, and also make our voice heard to policymakers when it comes to making policies that will affect local fabricators. So the EDFAC, what we found out is that we have over 200 members. As I speak, we are profiling all the members in the whole of Ghana so that we will know all the fabricators and their capacities. When I say capacities, I mean what they can do. Some people can do greater, others can do maybe a washer, and others. Out of the 200, we've realized that all of them, they can do a greater, only greater. When it comes to equipment for starch, none of them can do it. Most of the starch produced in Ghana are being done through artisanal means. Nobody has done a full processing equipment for starch. Once again, let's come together and break this record so that we can also use it to help our industry. At the moment, the Fabricators Association, we are at the Western North, still profiling some of our members. Challenges faced by fabricators. In most cases, the materials that we buy, for instance, when you go to market that you are buying stainless steel. Stainless steel comes in grade. You have 304, 316, and others. Because we always give us the wrong ones. Even when it comes to the thickness, all the members that we profiled so far, in the whole, it's a common problem. When it comes to the thickness, when you are buying 2 mm, they will give you 1.5. And you will challenge also a problem. Another problem is we've had a lot of instances where we ourselves, local fabricators, going to very modified Chinese equipment. I've received a lot of videos from people sending me Chinese equipment for gari, fully automated. Please, they are not as efficient as they look in the videos. And I am saying this for fact because I've been called to a lot of places to work on those equipment. Over the years, we can do it and do it better. Most processors also face a lot of challenges on our equipment. Because of time, I will share only a few. One, most processors, especially the small-scale industries, they don't have technicians. And they use operators. And some of these operators, we know their level of education and experience. So they will use these operators as technicians. And when we manufacture equipment, even when there is something as small as a bolt that is loose, they have to call you to go and fix it for them. Please, processors, I am begging you. Now, EDFAC is training people that you can, the Equipment Designers and Fabricators Association are training people that you can, we are recruiting people and train them as assistant technicians so that you can come and maybe hire some of these people to help you as technicians. Thank you, and God bless you.
Thank you, Dr. Ebenezer Haman. Now, the next speaker. So, the next speaker is Mr. Tete, Emmanuel Tete. He's coming to take something or educate us on the theme, the need to ensure quality of Ghana-made, that is locally fabricated machines, to sustain productivity of cassava processing industry. Mr. Haman, over to you.
Okay, thank you very much, Mr. Chairman. As you rightly said, my name is Mr. Emmanuel Tete. I'm from Gratis Foundation. And what I do at Gratis Foundation is that I'm the principal production engineer at Gratis Foundation. Now, we are located at Tema, at the industrial area, opposite the cocoa processing company. Without wasting time, and because of the brevity of the time I've been given, I want to go straight to the topic. But then I want to give a little overview of we are a department under the Ministry of Trade and Industry. And, what we do are three. Our mandate is three. We exist to manufacture agro-processing equipment, just like Dr. Hammer. We have been in that space for maybe a little longer than Dr. Hammer. And then we also provide engineering services to industry. When you come to Tema, in the industrial area where we find ourselves, there are a lot of companies there without machine shops. So we provide machine shop services to those companies. And then last but not the least, we give apprenticeship training to the teeming youth in Ghana. So we have people who come to acquire training at our facility for 3 years, after which they become ready for the job market or to go and set up their own businesses. So now to the substantive topic, the reason why I'm here. I'm supposed to be talking about the need to ensure quality in the machines that are produced locally here in Ghana. And the objective is to ensure that we are able to sustain the cassava processing industry. Now, so when we look at that topic, we'll find that the objective for choosing that topic is for us here to look at quality of machines that we produce. That's number one. Then number two, how the quality of the machines that we produce fit into sustaining the cassava processing industry in Ghana. So I will take a few minutes to look at some of the products that we can process cassava into. Dr. Hammer has made mention of some, and he nearly took the wind out of my sail. Yes, but still, I want us to look at a few. Okay, we'll look at a few of the products that we can get from cassava. Now, the first and the commonest is fufu. Fufu, we all know that we get fufu from cassava. Now, hitherto, or in the recent past, we bought the cassava and then we subject it to pounding by strong boys and girls with a pistol in a mortar. When I was young, I said I don't eat fufu because I didn't want to pound. Fortunately for us, in recent times, we have machines that can do the pounding of fufu for us, which has made fufu pounding a little easier than it used to be. Yes. When you come to gratis, we produce a lot of such machines for commercial as well as domestic purposes. The next product is gari. Doctor has talked about gari already, but it is one of the staple foods that we eat here in Ghana. And before we have our gari, it goes through a certain, processing stages to get it. Now, we first of all have to wash it, peel it, and then grate it like Doc said. Then after grating, you have to dewater it, remove the water from it, you sieve it, and then it will be time for roasting. Right. Along this processing line, we have a series of equipment that we use to do that kind of job, which Doc has talked about. So that for the grating, we use a cassava grater, some of which, or most of which, are self-feeding. Self-feeding meaning that you pour your peeled cassava into the machine and it is able to mill it for you to the end by itself without you having to attend to it. Then the dewatering, you can use either the single screw press, you can use a hydraulic press, or you can use a double screw press to dewater it for you. And then there is the sieving. The sieving, you can use Doc's machine, or at gratis, we have a very simple wooden device that can be used to do the sifting, and it is very, very efficient. Then it comes to the roasting. The roasting too, we have the mechanical roaster. And then because of the challenges associated with mechanical roasting, we have gone the extra mile to looking at how to enhance how it is done locally, how roasting is done locally, so that we can, retain the taste of gari that we are used to. So we usually provide roasting trays, which are big enough to sit on a hearth with fire under it to do the roasting for those who are into Gari processing. Right, so that is about Gari. Then we can talk about Kokunte. Unfortunately, Doc didn't make mention of Kokunte, but Kokunte is one of the things that we get from cassava. The processing method is chipping, then you dry it, then you mill cassava, right? And there are machines that we use for that as well. And then we have starch. You can get starch out of cassava. To do that, you have to grate it or mill cassava. Then you allow it to settle so that water will collect on top for the starch to be down, and then you have your starch. Now, so these are a few of the products that we can get out of cassava. So as I was talking, I made mention of machines that are used to mentioned. So that my mission here this morning is to talk about the quality of these machines, so that when they are used to process cassava, like Doc said, the cassava will be safe for consumption. That is my job here, right? So to do that, we first of all have to look at what it means when we say quality. What does it mean when we say that a machine or a product is quality, right? And by definition, quality simply means fit for purpose. So it means that for my machine, the machines we produce are gratis. The machines that Doc produces at his place, for them to pass any quality test, they must be fit for purpose. It is that simple, right? Academically, we have some indicators or some dimensions that we use to measure the quality of any product, be it food or an equipment, a machine. We have 8 of them. We have 8 of them. So for our fabricators, for gratis, to be able to produce quality cassava processing equipment, our machines must meet these dimensions that I'm going to talk about very soon. We must also be able to devise methods of measuring our equipment against the dimensions so that we'll know where we fall on the scale of all of these dimensions that I'm going to talk about. Now, like I said, the dimensions are 8, but in my estimation, and as somebody who has been in production for quite some time now, I don't think at our level of development as a country, we need to pay attention to all 8 indicators. There are some which are very crucial to us because of our level of development. Elsewhere, they can measure their equipment against all of these indicators because they have the means to measure it, and then also because their technologies are advanced. Down here in Ghana, and as we may all know, we are so many years behind the Western and the Eastern world. So, I mean, for me, I will suggest that we restrict ourselves to what we are capable of, doing and doing it right, and then we build upon that, as we try to develop. So the first quality dimension that we have to take into account when we are testing our machines as to whether they are quality or not is their performance. That is the first dimension, the performance of the machine. And what that means is that if Mr. Makhama says he has made a machine that, Dr. Makhama, if Dr. Makhama says that he has produced a machine that does sifting of gari to grade it, then how is the machine able to do according to Dr. Makhama's claim? He said the machine can sift. So for it to pass this first quality dimension, it must be able to do exactly as Doc has said. That is performance. So if I produce a machine at gratis, and I tell you it is able to grate cassava and be able to, you can determine the texture that you grate the cassava to, then the machine must be able to do exactly that. If you are able to do that, then you have passed the first one. But that is not the end. Then there is a second one, which is a features, the features dimension of quality. Now, what features means is, for instance, the cassava grater I made mention of, some of its features are that it is self-feeding. You can adjust a certain part of the machine to determine the texture that you want. It is able to discharge the cassava dough by itself and so on. Those are the features of the machine. So for it to pass a quality test, all those features the machine must, that we claim the machine has, when a buyer uses the machine, he must be able to use the features. Then reliability. Reliability is also a test of the quality of our machines, and that simply means that the machine must be able to work as long as you, the buyer, will want it to work for you. There are some machines you buy which break down very often. When that happens, the buyer or the producer will not be able to get the full value of the machine, and that will affect whether we are able to sustain cassava processing the industry or not. So our machines must be reliable. They must be reliable. Then conformance. Conformance is the fourth dimension. That means that there are regulators as a country, Ghana, we have regulators like the Food and Drugs Authority or the SDA standards, Ghana Standards Authority. They have, rules or regulations that we are supposed to follow in fabricating or manufacturing our machines. They specify the type of material you have to use for your machines. They tell you the noise level that your machine must have, and a whole lot more. So for your machine to pass any quality test, it must be able to conform to the regulations as spelled out by these regulating agencies that I have mentioned. And when it comes to cassava processing, because of the high content of water in cassava, the material we use to fabricate our machines is very, very crucial. And it has to be stainless. That is non-negotiable. And in some cases, you even have to go as far as using the highest grade of stainless. The highest grade of stainless. For instance, at Gratis, we fabricate fruit juice extraction machines as well. And because of the acid level of the juice, we are not able to use any other grade of stainless steel apart from the highest grade. Because if you risk and use any other grade, there will be the problem of the contamination, because there will be rusting. So the machine must conform to lay down regulations by the regulation authorities. Then durability. The machine must be durable. Durable means that it has to be available for use for a very long time. And that reminds me of an experience I had in the Ashanti region. Gratis did a machine for a palm oil extractor. And this man has been in the business for a very long time. A very long time. Now, the good news is that the machine that we made for the man is still in use. He has used it for over 20 years now, a palm oil expeller. The only thing he does is there is one component in the machine which with time it wears. So when it is worn beyond, it gets to a certain level, he will have to bring it, and then we either fill or we do a new one for him, and the machine will be back on the road to work. So the machines must be durable. But my CEO thinks otherwise, that if we do machines that last 20 years, very soon we'll be out of business. We'll be out of business, so we'll have to balance it. The machine doesn't have to fill frequently, and it doesn't have to last too long too. Maybe. Yes. Okay, so that's the fifth quality dimension. The sixth is serviceability. Serviceability. We must be able to service the machine anytime it breaks down. There are some machines which, when they break down, you can't even get the components, to bring them back on road. And that, is a disservice to whoever buys those machines. So, honestly, at Gratis, we take that into account a lot. We make sure that the parts that we use to produce our machines are always available on the market for use. Breakdown. Then we have aesthesis. I've always not been able to pronounce that word properly, but I think either aesthesis or something. It has to do with the beauty, of the machine. Aesthesis. Okay, thanks. The beauty of the machine. That also is a measure that we have to factor into the way we produce our machines. Then, finally, perceived quality. When people see the machine, what comes into their mind? What do they think about the machine? There are machines you see, and then right away you're able to tell yourself that as for this machine, it will work for me. There are, and then you think it will not work for you. Right. So these are the dimensions that we have to measure our equipment against to ascertain their quality. But like I said in the beginning, we cannot achieve all 8. Even if we are able to achieve all the 8, we will achieve some of them to a certain degree only. We'll be able to achieve them to a certain degree only. But because of our level of development, 4 of these dimensions are very crucial. I believe that if we are able to take care of these dimensions and take care of them very well, we will be making inroads into sustaining the cassava processing industry here in Ghana. And here are the dimensions that I'm talking about. The first is a performance. When we say it's a grater, it must do the job of a grater, and that should be it. That's the first one. Then the second is reliability. It doesn't have to break down frequently. Then the third is conformance. It is conformance because food safety is very, very critical. It is very, very key. If you don't use the right materials, you will not get it right, and the quality of the machine will be affected. Then serviceability is a fourth. Serviceability. When the machine breaks down, we must be able to bring it back on course. The rest are not so important as far as what I have been doing over the years is concerned. Because when you look at aesthetics, for instance, most of the machines that we do are virtually handmade. We do not have process machines that help us to manufacture the machines. And by process machines, I mean machines which are dedicated to do only certain parts of the machine, and that one alone. We don't have that in Ghana. All that we have are the conventional ones, which require somebody to always be by the machine, a skilled person to be there to work on the machine so that you arrive at what you want. And the skilled person will always have to be measuring, will always have to be punching, for instance, a plate at a certain point. So naturally, the products that we manufacture will not be as nice, as good looking as the ones that come from elsewhere, okay, where they use process machines. Right, so that is all that I have to say. If we are able to stick to the quality dimensions I've mentioned, then we'll be making progress at sustaining the cassava processing industry in Ghana. Thank you very much.
Thank you, Mr. Speaker. And that is Mr. Emmanuel Tete for doing justice to the topic. So now, I think we are getting to the point where there will be questions and answers and at the discussion panel. Now we have, as we all know, Engineer Dr. Beneza Kakra Hammer, and then Mr. Emmanuel Tete. Now, there is Mr. Wisdom Kofiga from Accra Brewery, and then Miss Letitia Akoma. So, hello. So now I put some point here to be taken into consideration. So we have, from the presentation of the two speakers, we have material selection and quality assurance difficulty. That is, for example, how do we test if you are given a high-grade stainless steel? The manufacturer said, this is the stainless steel you have, the highest. You pay for it. What equipment do you have to confirm that quality? That is one. And then I don't know if I should read through so that all of us be thinking about it. So two, so from the marketplace in Ghana or let's say outside, how, for example, all the materials, either they are imported or manufactured within. In the process, we need, from the beginning, quality. There are certain percentage of certain, let's say, iron content in, I'm speaking from a background as a materials engineer. Iron content, for example, the one we do in combi machine, the one they mold, during milling, it peels off small, and when you cook with it, with time, you may be hammering yourself. So something had to be done in that. There was a publication from KNUST concerning that. Now, in cassava processing, I'm sure is still contact with, they still get in contact with the product. So the question is this: how do we avoid wearing off parts of this, translating into contamination with time? Then And I know part of these are not in your domain, it is within the domain of manufacturers. But you have to confirm to establish whether the stainless steel has that quality. Then we move to the production. That's what I've just mentioned. And then, again, I also said, do you have that device? Now, what is the relationship between Gratis and the Association of Equipment Manufacturers in Ghana? Gratis seems to be an agency under government. They might have more influence for government to help you people to sell your equipment or have market for it. Do you have Gratis? Do you have that association with the local manufacturers, that relationship with the local manufacturers? That is also going to Gratis. And then now, what is the relationship between the Association of Local Manufacturers and government? The necessary ministries, is it Ministry of Trade and Industry, or is it Science and Technology Ministry? What is the relationship between the association? That goes to the association. Then we're talking of, now, we are talking of global village. Africa is one. It's only divided by colonial masters. Do you have a relationship between African manufacturers in Nigeria, be it Zimbabwe or whatever, to make you outside Ghana for marketability? And then, yes, that is exactly what I mean by what is your market value, your market, whatever. Now, to end it all, Ghana, we have Engineering Council, and then who have an association of, that is a Ghana Institution of Engineers, that are supposed to, the responsibility of the engineering institution is to ensure quality assurance of any engineering practice. And manufacturing is also part of engineering practice. Do you have any association with engineering, Ghana Institution of Engineering? I think from my end, that's the end of what I have for the time, and the audience will follow. Thank you.
All right, thank you. When it comes to aesthetics or aesthetics, whatever, to me, I am the president of Equipment Designers and Fabricators Association of Ghana. The world is changing. When it comes to equipment fabrication, it's a hygienic equipment. We don't compromise. It is this aesthetics that we don't have. That is what is taking us out of market. Packaging has become very important. So I am of the view that we don't have to compromise aesthetics. That is my opinion. And I will encourage all our association members to strictly adhere to the aesthetics as a quality of a machine. Because, one, I work for WFP. I've manufactured a lot of equipment for WFP, not only in Ghana, but in Burundi, Chad, and Central African Republic. I have built the biggest cereal processing factory in Africa, which is Premium Foods. And when you go there, you will not see that, you will not see any difference between the foreign equipment and the Ghanaian and the Ghana-made equipment. I'm not here to blow my horns, but I want us to have that quality. Yes, we can do it. So when it comes to aesthetics, it is also part of it. That is my opinion. When it comes to association, I am a member of EHEG. EHEG is European Hygienic Equipment Design Group. And so I'm a member, and also a member of Ghana Institute of Engineers. Also a member, a fellow of Ghana College of Scientists. So we have to position ourselves so that strategically we will expand our market. Another relationship between Gratis and Makama. I used to be a consultant for Gratis under Makama Engineering for 4 years when the old CEO was there. And through that relationship, we were able to build a lot of equipment for them. In fact, I will say this, he's here and you can't deny it. It is our time that Gratis became popular when we had that relationship, because there are a lot of equipment that Gratis can do that we do. I'm not trying to condemn anybody, but it's time that we should build that healthy relationship among ourselves for us to grow. We don't have to compete among ourselves to bring ourselves down. Another is when it comes to how you can identify whether this is, as an association, we've called upon standard authority concerning the issues that are raised in my presentation, how we are going to solve that problem. In fact, it's a menace. You have to stop it, else we are going to die. When it comes to food, you don't have to compromise. So we are working on it. And as an association, we've written a lot of letters to all the authorities involved or the stakeholders to make the association known so that they can give us all the necessary support. Thank you.
Okay, so in fact, in those of us who are the user side of all the machines that are manufactured, particularly I work in Accra Brewery, and we make use of high quality cassava flour in our products. And so the quality of machines that are manufactured, looking at reliability, for instance, because we don't do so much of buffer of materials on our site. So we rely on the stock available at the manufacturer's end. And so if the equipment is not reliable, it's a big risk for our operation. And also, those of us in food industry, we are highly concerned about food safety. We are highly concerned about hygiene of equipment that are manufactured. So we have, through our HACCP system, we have established accreditation programs that we do for all suppliers who actually use these machines to produce for us. And so before we can even onboard you, the first thing we do is that are built in the machine that can ensure the quality that we need, the food safety standards that we want to adhere to. And it is a risk of iron in some of the products that may come as a result. And so we have standards for all these heavy metals in the product. So we have standards that we check against. First of all, most of our standards are established through what we have globally in the Codex Alimentarius, Ghana Standards Authority, in terms of the limits or the standards that are acceptable in our region. And then based on that, we come to an agreement. If our global standards are much stricter, we definitely go by that. Where we don't have standards at all, then we go by the local standards that are available. And we insist that the local processors or manufacturers are able to meet these requirements, because we can't put the consumers' health to that risk. And so we make sure that we achieve this before we onboard them, and we continue. So annually, based on the level of output of the manufacturer, we have annual programs. If they are not able to meet our accreditation program, we have between yellow, red, and green suppliers. That's the status of suppliers. So if you happen to be a red supplier, we cannot take any material from you. If you are classified as a yellow supplier, we believe you have the potential. And so what we do is to work in partnership with you so that you attain this standard. For the green supplier, we do every 3 years, we do the audits. And while we receive supplies from them, if there are feedback we need to give them through complaints, we share that with them. We demand for solutions. We demand for root cause analysis from them so that we know the challenges they have and then what they are doing to resolve all that. And I'm happy to also mention that we have been beneficiaries of some of the products from Dr. Mahama. We also receive materials from Premium Foods. In this case, not cassava, but we receive maize grades from them. And so I'm happy to meet him in person today. I have not met him since. So thank you for the program as well.
For the food safety bit, I want to talk about it. So when you grate cassava, likelihood of you getting that the iron in the grater into the food, it's possible. But when you ferment, it takes care of the iron. So it is advisable that when you are doing gari, you should allow it to ferment, because the fermentation takes care of that. It's like a quality check. This is that causes the iron to oxidize. So those are some of the food safety checks that can take care of the iron that is leaching into the product.
No, I'll not banter you. All right, thank you. Well, I think Dr. Makhama asked us to move most of the things I'm supposed to have, reacted to. But there is one here, testing of materials. How do we determine the quality of the materials that we use? It has been our headache for a very long time. Because, like I mentioned, we are at the forefront of the manufacture of agro-processing equipment in Ghana. We are the only institution in Ghana under the government that does that. So it means that we get large orders to produce such machines for end users. But we are not able to determine the quality of the materials that we use. Previously, we used to rely on our spectrometer to tell us about the components, chemical composition of the material, so that we are able to establish whether indeed it's a high-grade stainless steel or not. But the machine has broken down, and we've not had funding to replace it. So from the time it broke down to date, we are not able to determine the quality of the materials that we use. And honestly speaking, that is the only means by which the quality of a material can be established, using the spectrometer. So as the dialogue goes on, I know someday this information will get to some quarters, and then somebody may want to come and assist gratis so that we acquire that kind of machine. And like Dr. Hammer said, we do not have any collaboration with their association. Until I came here today, I even didn't know about their existence. So today that I've met him again for the second time, I will make sure that I ignite some rapport with him so that when we get back, we will see about how to work together and then get gratis on board that association for cross-fertilization of ideas. Thank you.
Yes, so I want to ask from Dr. Harmer, you run training for people, fabrication, other thing, or technicians, kind of things. Is it accredited, or is the certificate recognized? Thank you.
As a company, we trained people for free. We've been training a lot of people for free. And we are now setting up a skill training center. And this skill training center also has what we call African food processing technology. So now, we are not accredited by any organization or by any accredited body yet. But in our new establishment, we are going to get all those things on board. Once I've been given the opportunity to hold the mic again, let me address this quickly. Engineers don't think like businessmen. So when you are doing something, don't say you are doing something that will spoil tomorrow for somebody to come and buy. You have grades. So either you tell the person that this is 20 cedis, this is 10 cedis. So if you buy 10 cedis, it will last this. If you buy maybe 10 cedis, it is going to last. When it comes to iron deposit into food, I told you I am a member of EH. The most safest material for food is from the earth, which is ceramic. Or wood that has all the properties as food. So iron coming into food has been a problem ever since. The best means is for us to be selective when it comes to the material that we use. Thank you.
Yes, sir. New Data Mills, and I want to talk to the man from Gratis. I attended Tematech, yes, and I know how machining is a difficult thing. To be able to be producing items on like large quantities, is it possible that you can talk to the ministry if they can introduce e-beam, the electron beam machinery at your place, because it is one of the fastest and the safest way to produce parts accurately. So at least with some of your milling and all machining works, that takes a lot of time. That one can help you produce more of that in terms of spare parts. Because if the demands are very high, then Gratis is going to go down. And I know some of your late machines, they are over 20 years. Yes. So what are you going to do? Is it possible you can talk to the ministry so that they can help you with a machine of that stature? Then I think your products will also go forward.
Right. Thank you very much. Talking about our machines, and specifically the one you made mention of, for your information, we used to have CNC machines at Gratis. One milling, the other lathe, both CNC. And then we even had an electric spark erosion machine as well for spare parts production. Right. The unfortunate thing is that all these three machines have broken down, not as a result of negligence, but because we lack the spare parts that it takes to bring them back on stream. So as we speak, we are in talk with some people to see how, you know, we can come together and acquire those spare parts that we need to repair them. The ministry is in the know as to what is happening at Gratis. So we are even looking at maybe scrapping the old machines and then getting new ones. I'm talking about the CNC machines. It's something that we are looking at, and I'm sure now that it has come up here again, somebody like, I will say, will hear it, and then some support will come from somewhere. Thank you.
Hey, I want to find out from Dr. Hammer and Amwakwa. She is in charge of our gari processing and all other stuff here. And Dr. Hammer too. You mentioned about a machine that they use in frying, or I don't know whether it is frying or roasting gari. And then it can't taste the same as the one in the conventional way. So Amwakwa has been using the conventional means to do that. What is the missing link? I don't know whether it's Amwakwa who will answer first or...
Thank you. I think I missed something. You said you've not heard about our association. We are still, I said we are at this thing. So we will come to Greater Accra and register all the relevant people that we think they should be involved. So very soon we work together. Of the machines, most of the mechanical gari roasters uses gas, and the heat is very when it is just about to be ready for eating. So the heat is very sensitive. So at a point, regulating the heat from the gas is very difficult. So if you don't take time, it will burn. Just when you're about to take it from the fire. That is one. Two, the stirring and trying to break the lamps is a problem. The mechanical one, though they've done a mechanical arm that tends to break the lamps just like the local roasters do, but it is not as efficient as the way they do it. And I don't know, the taste always is not the same. So we are finding out, I believe, that is my belief, that if it is a machine, it is possible. So we are still trying to find out and better it and make it well. For me, I don't want to bring anything into the market that doesn't have the quality that people want. So I don't rush to bring things into the market. I don't have any mechanical fryer in the market because I know there's a problem with it. In Ghana, when you are a Ghanaian and you are fabricating equipment, if you don't take time, they will spoil your name. So I don't want that. I just always want to do what I think is quality, meet all the standards that my brother explained to us. Thank you.
Yes, like you are saying, the mechanical one, with me, I know exactly how it works. Yes. With my suggestion, is it possible, you see, conventional one, they normally use wood. Is it possible the turbines of the mechanical one can be changed to wood? Because I feel the heat that comes with the conventional one, in attached to the wood, produces some kind of gases into which, you see, when you are burning firewood and you are cooking with firewood, it sometimes brings some of the smoke and stuff, which also gives the taste a different way. So is it possible that the turbines of the mechanical be changed and try with the wood? So at least if the heat is producing and this one is stirring, it can maybe have effect on the taste also.
Thank you very much for the suggestion. I think right away I will put that input in our research and try it also in C, because everything is possible. In engineering, when you try and you're not getting it, everything is possible. Thank you for your input.
So I think it's high time engineers collaborate with food scientists in development of equipment, because flavor formation, how the mechanism by which food cooks, all contribute to how the individual perceive the food. So if you are using, like he said, if you are using wood to cook, smoke has its flavor, and then it adds to the food. So a lot of people will tell you that jollof that is prepared at home and the one that is prepared at a funeral doesn't taste the same. And it is because of the smoke that the oil absorbs the smoke and then it adds flavor to the food. Now, when you are roasting gari, the conventional way of roasting gari, they allow the pan to get to a certain temperature before they introduce the mash into it. Now, cassava has two main molecules that normally we food engineers use it in developing products, and that is the amylose and amylopeptin. And both of them relate to heat differently. And so if you don't get to that temperature, when you are in the initial stages of the roasting, if you don't have that temperature, you put the mash into the bowl and then it becomes powdery. So you have to get to that temperature. Now, when you get to that temperature and you start roasting, in most cases, they allow they will heat the gari for steam to build up. And the steam that builds up also adds to the texture of the gari. So all these things, it's not just about stirring, but that mechanism where you allow the steam to build up. When the steam builds up, you open it up for the steam to escape. all these things will contribute to how the texture of the gari will be. So there are some gari that they call it gari biscuit because it's crispy. It all depends on the moisture, the initial moisture content before it was introduced into the pan. And if you don't get, if your gari is dry, in fact, if you have a moisture content of about 45%, it's likely that you won't get that gari biscuit. So if you want gari biscuit, then you should get a certain moisture content. Your temperature should be accurate. And then the way you stir should also be uniform. So when you put the gari in the pan, you wait a little while for the amylose and amylopectin to react to the heat, and then you start stirring to break the lumps. And then at a point, you allow it for the steam to build up before you start stirring again. So all these mechanisms contribute to the texture, the taste, and then the flavor that you get from the gari. So maybe with time, we can work together to develop a mechanical fryer that actually gives us the best gari. I know Nigeria is doing it. I don't know if you've heard of Niji Foods, but he has automated all his processes and he's getting the right taste for his market, like the right taste. His gari, they call it Ijibo gari or something. Nigeria has about 80 ways, 100 ways of preparing gari, and he's always getting the consistent taste that they want. So I think food engineers and then, I don't know, fabricators should start working together so that we can incorporate some of this cooking mechanism into the machine so that it gives us the best outcome that is the consumer will accept.
Thank you very much. I think we are making a headway to solve a problem that has been bothering us for so long. You were asking whether we have some collaboration with food scientists or something. Yeah, food processes. My organization, Makama Engineering, has a collaboration with the Food Science Department of Legon and also Food Process Engineering. Even they bring some of the students there for an internship because we manufacture food processing equipment. And there have been some cases where I personally have fall on professors like Professor Sifadede, Tanoda Brasalia on machines that I want to do because I need some, professional advice on how to go about it. And even our association will try to make some of them live patron so that they will help us when it comes to set related problems. Thank you.
My name is Koku Ajimai. I'm from Franzacos Company Limited. We produce cassava flour and gari. Usually, when one wants to start any manufacturing business, we do not look internally for the machines. For most of these local engineers, as Dr. Hammer rightly said, the presentations are not too good. So when you compare with machines from China and other places, you're forced to go to China. The prices are better than in Europe, but then the qualities are comparable. So when we wanted to start, we had to go to China, visit some of their manufacturing industries. And they sent us to plants they have built so we could see firsthand how the machine works. And we place orders and they shipped it down. What happens is that some of these Chinese people, you can't trust them. They show you one thing and ship a different thing to you. So when it came, he needed some other components to make the plant fully functional. So the consultants who were helping us introduced us to Dr. Hammer. So he came to the factory and we discussed what we needed. So in one of the presentations, there were machines from the factory. The grater, washing machine, the slicer, and co. Dr. Hammer did it. And I want to commend Dr. Hammer. But when he does the machinery, and you see the imported ones, you will not be able to make out the difference that these are locally made and these ones are foreign. The presentation, the finishing is very, very good. The finishing from Dr. Hammer's end was very, very good. So as for our local engineering companies to team up, make sure the finishing is good. At least paint it. Paint it. Even if the welding ends are not that good, when you paint it, it takes on a different look. And the other thing is that you want to collaborate with those you manufacture the items for. But when you start processing, there are always challenges. You don't finish one and it works without a problem. Always you encounter problems. So for us with Dr. Hammer, the issue has been, he's in Accra, we are in Ashanti region. So monitoring is a bit of a problem. But then that is one area we want to encourage. If you come and see how the machinery is faring, and you can always improve it. As you examine how we put it in operation, you can always improve it. And when it comes to the Gari machine, we tried it. And as Dr. Hammer suggested, those imported usually do not work. So we had a small one that we were about to create manually. But the issue was you spend about 20, 30 minutes and you produce just about 2 kilos. How do you pay the number of people working on it? So for the whole day, maybe your best is about 20 kilos. You employ people who peel. You pay them. Those who fry and all electricity costs. So we realized that the manual thing will not help. So we had to start developing a mechanical one. I'm happy to announce that we have a mechanical one in operation now, and it works. It works. We tried developing it with a local engineer, back and forth several times. We wasted a lot of fortune on that. Fabricate, we try, it doesn't work. We change the motor, we change the arms, several things. And at this stage, we try to improve on certain parameters until finally we're able to get the mechanical thing working. So we have it. But don't come and copy, please. Don't come and copy. So we have the mechanical system working. We've gone through a lot. Because if you come, we've gone through back and forth before we could get that mechanical system. The taste is perfect. The taste is perfect. Only my Gari is more expensive. It's not. The same applies to cassava flour. It goes through all the systems. We produce 250 microns. So the sifting, we have to do sifting. So getting, let's say 50 kilos takes a long time. And the labor, you can imagine. So it's not very cheap. We have to go through all that. See, one thing is, we don't have a farm yet. We buy from our. When cassava prices go up, we are not able to cook. The whole of January up to April, we could not process one day because the price was said that we could not break even. We're now trying to go to farming. In fact, that is the reason why I came. I mean, what the atomic energy is doing for. When we get into farming, we will need that. So when it comes to fabrication, we need to collaborate. After you've designed it, please come back to the factory and see. And together, eventually, we should be there.
Thank you, Mr. Ajiman. Now, I think questions. Okay.
So I'm Dr. Samuel Neti. I want to commend Ajiman. He called me on when he saw the flyer, and then he had come all the way from Kumasi. Okay, but Mr. Juman, your innovation, if you keep it to yourself, Ghana will not move on. So is there a way that maybe the local manufacturers to maybe pay something? You say you spend a lot, and then this must be disseminated not only at your doors, but to the rest of the country in a way. So you can make a cashback sort of by going into agreement with some of the local fabricators and then other companies that may need it. Is that possible? And then also on the issue of the cassava planting materials and then its cultivation, which is at the right place, at the right time, we should talk about that. Thank you.
Yes, I think when you invent something, you do what? Patent it, and then anybody who goes into it pays a royalty. So it is possible. Now, any other question? As we yes, he will answer right. But I want to know if you have any other questions, so that because we are to close at 11. Is that it? We can go on a little. Any other questions? I want to get them around as Mr. Jiman answers the question. Hello, sir.
Well, if you want to buy, we can make one for you. Just giving out the technology will not be in our interest. If you want to buy and later maybe copy and duplicate it, fine. We can sell to you. We can sell one to you.
Thank you once again. Please, let's, this is our industrializational agenda, whatever. So, good.
I want to commend and thank our Mr. Ajiman for allowing his establishment or his investment to go waste or in the name of trying to come out with something good. I think this is something that other processors should also learn from, because some of them, even when you bring a machine from China, sometimes it comes with problems. You have been very patient with us. Some of the machines, during the installation, there was some distance. He's been very patient. He called my people always to go and do one or two things, and now everything is okay. So I am just appealing to others to also be patient with the fabricators so that they can get the best. Thank you.
Yes. Any question online? Okay, so BNARI, you have done so much, especially in mechanization. I never knew. I thought you only grew, seedlings, not knowing you are into heavy engineering activity. I want to also introduce to the sittings all who are into fabrication, welding. Ghana Atomic Energy Commission, in the Department of Non-Destructive Testing, after weld, you have to carry out a test. We do that. We do that in our turbo plant, wherever there is fabrication. I happen to be a member of that department, so I think we can have this collaboration. So when talking of standard, we can play a role. In the absence of any question, I don't know, how do I close it? Okay, so I bring the session to close, and yeah, okay. 10 minutes break.
That's how the rights come. Then we come back, we'll come back in 5 minutes. We have our next section in the next 5 minutes or 10 minutes, and then the panelists are already here. So please, let's give a round of applause to our panelists for the first section. We're hoping that they will wait a little to listen to the next presentation, because that has to do with energy. You can't fabricate the machines without thinking of energy. So if you have a few minutes to wait, we would like to have your presence. Thank you. We have 10 minutes health break. So our audience on. Welcome back to the second preliminary section, where we're going to have a presentation from the Nuclear Power Institute of Ghana Atomic Energy Commission. They'll be presenting on the topic GAEC's role in ensuring sufficient and sustainable energy for Ghana's cassava industrialization agenda. We have a team from the Nuclear Power Institute to handle this topic and then to address our various questions. We have Mr. Joshua Gbino. Okay. We have Mr. Joshua Gbino, and then we have Dr. Felix Ameyao. And then the person among the team who will be doing the presentation will be Mr. Festus Drew Kwanzaa. Shall we give them a round of applause? To lead this panel discussion, this section is our colleague here at BNARI, Biotechnology and Nuclear Agricultural Research Institute, in the name of Dr. Andrew Sarkodie. Sarkodie Appiah. All right, thank you, Sarkodie Appiah. Dr. Andrew Sarkodie Appiah. Your audience, this is your moderator. Thank you.
Thank you once again. And you're all welcome to the session 2 of day 3 of the Cassava Week celebration. Those joining us online, you are all welcome to this important session. Yeah, the speakers for the session 1 spoke extensively on machine design and fabrication. But you all agree with me that one cannot design or fabricate machines and operate machines without energy. On this note, I will say that energy is the foundation stone of every modern industrial economy. And for this reason, sustainable energy production is key to the industrialization of cassava. This morning, we have an important person here, in the person of Mr. Festus Drew Kwanzaa from the Nuclear Power Institute, who's going to speak to us on GAEC's role in ensuring a sufficient and sustainable energy for Ghana's cassava industrialization agenda. Ladies and gentlemen, We have in the house Mr. Kwanzaa. Mr. Kwanzaa, your audience.
Thank you.
Your speaker. Thank you.
Thank you very much. It's a pleasure to be part of this conversation about developing the cassava industry and its general effect on the Ghanaian economy. I'm Festus Kwanzaa. I work with the Nuclear Power Institute, Energy Planning Center. And I will be sharing on the work that we are doing as an institute in relation to Ghana's nuclear power program to support Ghana's industrialization agenda. Okay. I'll go ahead. You try to with the presentation. No. Oh, if you can project. There's a copy on this pen drive, so you can project from somewhere. That should be fine. Okay, so to begin my introduction, to begin with my presentation, I will lay a premise in relation to the energy and economy nexus, or the link between the energy sector and the economy. That really forms the basis for our conversation. And I'll move on to talk about Ghana's nuclear power program, what you have done so far, where we are now, and also touch on what I call the nuclear power advantage. There are many sources of energy that any economy could use in propelling the development of the economy. But why nuclear power? Is there any value proposition for nuclear power? Would have to appreciate that. I'll also share with you some findings on a technical study that we did in 2016 and updated in 2018 on the macroeconomic impact of nuclear power, specifically for the Ghanaian economy. I'll link our analysis to Ghana's cassava value chain and the potential that we have as an economy that we can tap moving forward. And I'll share some conclusions from there. So basically, it's a stylized fact or general truth that when you increase production of electricity in an economy, you in turn increase productivity in the economy. And it's true for a lot of economies, and the Ghanaian economy is of no exception. Because if you look at the data of Ghana, I wish it had been projected, but I could probably draw some analysis from there. If you plot the economic data of Ghana in terms of GDP growth and consumption in the economy, you could see that there is an upward trajectory in terms of, so you can take it from there. Yeah, you can connect to this one. In terms of how much electricity is being used in the Ghanaian economy and its corresponding growth in the economy. So if you plot the data from, let's say, 1990 downwards to 2000 and use this one. I'll read from here. So you can project from here. framework to support the program and the project, to safeguards, to regulatory framework, to radiation protection, to ensuring that the grid is strong enough to take on power from a nuclear power plant, to human resource development, the manpower to manage the plant and all that, stakeholder involvement. A nuclear power program involves more than just building a power plant. It involves interaction with the community. It involves different institutions in the country. So all these have to be properly aligned as a country. You have to talk about sites and where do you place the plant. Is the site good enough to house a plant? All these technical analysis have to be done to ensure that the project is successful. There are issues of environmental protection, there are issues of emergency preparedness, nuclear fuel cycle management and all that, nuclear security, radioactive waste management, also very critical in there, then industrial involvement in the program as well as procurement. So these 19 infrastructure issues are very critical to making sure that the nuclear power program is very successful. And there are 3 phases to the nuclear power program. The first phase involves the country doing all the technical analysis and research in all these areas to arrive at a decision by the government before it goes on to do feasibility studies. So the first phase basically involves a technical work which includes arriving at a pre-feasibility study. So when a decision is made to move to the second phase, then pre-feasibility studies and feasibility studies are the plant. So it's actually a long-term project. And this is the milestone approach that has been suggested by the IAEA, and Ghana has followed it to the second phase. At the moment, we are basically at the beginning of the second phase, doing a lot of discussions with vendors and all that. So Ghana's nuclear journey really began way back when our first president started the reactor research project. But in terms of commercial production of electricity and a nuclear power program that will culminate into building a power plant, work began in earnest from 2013, where our former president, J.A. Kufuor, established the Ajay-Bekwe Committee to look into the possibility of engaging in commercial nuclear power production to support our economy. So the committee recommended that indeed we can take nuclear power as a technology to add to our energy mix. And that was when nuclear power was included in the energy plans of Ghana, so that we consider it seriously and we take it forward. So at the Ghana Atomic Institute, the role that we've really played is to establish a nuclear power center that later evolved into a nuclear power institute to coordinate all technical work and research work in the area of nuclear power, and also coordinate other stakeholders in the country, Energy Commission, Ministry of Energy, and other stakeholders who are all important in getting this project going. So moving from 2016, we have conducted a lot of technical work and submitted it to the IAEA. And all the processes have involved IAEA governance. Every now and then you submit your documentation to the IAEA self-evaluation report. The IAEA sends an expert review mission to look at our progress so that we dot our I's and cross our T's and ensure that you're on the right path. So we engage in these discussions. The IAEA makes recommendations and suggestions so that we improve the work that we've done to submit our report to the government and ensure that Ghana is on the right track with pursuing nuclear power for the country. We've gone through all those processes, and at the end of phase 1, we produce what is called the Program Comprehensive Report. What was submitted to government or cabinet through the Ministry of Energy for a decision to be made, an eligible decision to be made, that is, are we at a phase where we really understand what nuclear power projects are about? And the information that is captured here has been vetted by the IAEA. Included, the suggestions that were given were all included into an 8-chapter document that we submitted to the government of Ghana to make a decision on moving forward with the nuclear. The president of the country made a formal announcement that indeed we are in a position to continue with the second phase of our nuclear power program. And this formal announcement means that we can move on with our nuclear power project, engage vendors, and understand the technology more, to look at the financing options that we have, build further competencies in managing a nuclear power plant, and also strengthen stakeholder relationships, move ahead with siting analysis and siting work to arrive at a site where we shall place our power plant. So this is the progress that we've made so far. We are envisaging that moving forward, we have a site now. So we are envisaging that moving forward, regulations and siting regulations will be completed and a siting permit will be given, so that given the discussions and contracting that we have with our vendors, we'll conclude on a technology for the plant, financing discussions and contracting, then overall feasibility report before construction and operation can be done. And we are looking at a timeline of around 2030 if everything moves in a normal mode. So that's where we find ourselves now. One may ask, why nuclear power? There are several energy sources that every country may use. Solar, wind, thermal energy. But what is unique about nuclear power? What is the value proposition for using nuclear power on your grid or in your energy system? The promise that nuclear power really has for an economy, and we are having a conversation about developing the cassava industry and ensuring that we are competitive as an sources. So if you have a chance to review the literature or analyze the economics of nuclear power, you realize that operating a nuclear power plant is relatively cheap because of the cheaper source of fuel. The nuclear power plant basically uses uranium. And compared to other sources like thermal that uses gas, it is cheaper to operate. Also, if you look at the levelized of electricity cost for nuclear power is very competitive. But economists will analyze all these costs and divide it by the amount of electricity. If you compare the amount of electricity that a nuclear power plant is able to produce for an economy, and you levelize it with its cost, you realize it produces cheaper electricity. So the conversation about supporting the cassava industry then comes in. And if you tie this cheap electricity to that conversation, then we are talking about being able to produce electricity at a cheaper cost. That adds up to the overall cost component of the cassava value chain. So we are talking about labor costs, we are talking about cost of procuring machinery, transportation cost. That energy cost component is reduced when you use nuclear power. We conducted an analysis in 2006 and realized that when thermal sources were brought on board to solve the doomsday issue, cost of electricity actually increased, and it's always passed on to the consumer, be it households or the industry. So with the onset of nuclear power, the promise really is that if we're able to manage and optimize our costs very well, we'll be able to produce cheaper electricity for the country. Nuclear power also produces what is known as baseload electricity. And for every electricity market or electricity system, you want to have a power plant that is capable of providing enough or massive amount of electricity to support other sources, so that when demand peaks, it is able to provide what is known as a base load power to support other energy sources. If you rely on, let's say, wind, when the wind is not blowing, you have a problem. If you rely on solar power, if the sun is not shining, you have a problem. If you rely only on hydro, which has been the case for a lot of hydro, which has been the case for Ghana over the years, you realize that there was a moment when Akosobo was, I think, drying up, and I think there was even gathering to pray to allow for rains and all that. I believe in prayer, but there's also technology that allows for an electricity system to function. And that is what nuclear power does. Nuclear power is very strong enough to provide that base load power that supports an economy. So if you go to other countries like advanced economies and you realize that you're not experiencing power outages, most likely they are using nuclear power. Recently, there was news that Finland is producing power at zero cost, and that suggests that you can get more electricity because they had increased their supply of electricity through nuclear power, meaning that you can get more power at the same cost that you are purchasing. So if you really want to have a promise of reliable, sufficient, stable power in the Ghanaian economy that is cheap, the nuclear power is really the way to go. We are also having a global conversation about net zero emissions by 2050 and meeting our climate change targets. Nuclear power is one source that has actually been recommended by the UNFCCC to provide this kind of energy that is clean enough. It doesn't emit gases like methane that are not friendly to the climate. So when you are talking about climate change and meeting our climate targets, nuclear power is really clean enough to meet our energy demand. For instance, you can operate them for about 40 to 60 years before you decommission, meaning that if Ghana is going to think long term, if Ghana is going to really plan its economy, if you are going to talk about industrializing through Cassava, through other base load energy that can be there for the long term, and nuclear power provides that benefit. Beyond electricity, nuclear power also provides what may be known as non-electric applications or benefits. So the engineers call some heat. You can use nuclear power to produce hydrogen. You can use nuclear power to produce water and salt through desalination. So products or outputs that can also earn revenue for our country. So if you put all the dots together, nuclear power really has a lot of advantages beyond a lot of electricity. And we have to expedite action with pursuing this power program to benefit the economy. If you read history, you realize that our first president actually wanted to pursue a twin power project for the country. So when Akosombo was built, the next plan was really to build a nuclear power plant before he was overthrown. So around 1963, when Ghana Atomic Energy Commission came into being, all these plans were on the table, but some way, somehow, that plan was jettisoned over the period. So we only had Akosombo in our energy mix, and we have not been able to do nuclear power. I think we don't have any more time, and we have actually lost a lot of time over the period. And it's time to pursue a nuclear power plant project to support our industrialization agenda. We actually conducted a technical study because this conversation about cassava industrialization, economic transformation ties into overall conversation about the macroeconomic impact of a nuclear power plant in Ghana. And we had to conduct a technical study to understand the real impact of pursuing a nuclear power project in the Ghanaian economy. So these are some of the questions that we sought to ask ourselves. Does deployment of nuclear energy hold any promise? What are the benefits of nuclear power to macroeconomy? We also wanted to understand in terms of quantifying the impact of an increase in energy supply through nuclear technology and its effect on the Ghanaian economy, and conclude whether there is a macroeconomic or investment case for choosing nuclear energy in Ghana. So we had to use data from the Ghana Statistical Service, known as the social accounting matrix. So this data actually captures a snapshot of all the transactions going on in the Ghana economy in monetary values. So that's the data that we use to model the effect of nuclear power in the Ghanaian economy. We also use the Integrated Business Establishment Survey. That document provided us with values of incomes in the economy and the employment generation or the number of jobs in different economies in the Ghanaian economy. So when we modeled, we wanted to look at key indicators such as output in the economy, the value that's added, the income that is accruing to labor, and the employment generated in the Ghanaian economy. We realized in our analysis that by introducing nuclear power into our energy mix, the effect, because energy is consumed by different sectors in the economy, so we realized that there is an effect when that amount of electricity is introduced in the economy. We realized that gross domestic output or product was increasing by 10% by the introduction of a mega project like a nuclear power plant. A mega project really means that we are spending beyond 1 million USD in the economy. And that's very substantial. It means that the output in the economy is going to grow. That output also translates into several jobs across various sectors of the economy. And comparing nuclear power and other energy sources, you realize that nuclear power plants are the single sources of the highest employment generation compared to any other energy source. You cannot compare the number of jobs that is created by a nuclear power plant or the number of hands that are working on nuclear power plant to in the world. So you realize that the economic impact is very massive, and so it's a worthy project to pursue. And the economic impact really occurs at 3 levels. When you choose to construct and operate a nuclear power plant, you generate employment and you create incomes by the construction and the operation of the plant. This level means that when you are constructing and operating the plant, you source certain things, so the supply chain also induces. So for instance, nuclear power plant, you need cement, for instance. So if you are going to procure a lot of cement from Ghana, let's say Jata cement, that's also going to induce an additional layer of income and employment in the economy. Then further downwards, a nuclear power plant also creates an induced employment and value added, which means that the spend in Ghana chooses to sleep in a hotel. He's going to spend and also create incomes at the tourism sector and all that. So there is actually a multi-layer of a nuclear power project on the Ghanaian economy, which makes it very worthy to pursue. Our study also revealed that the secondary industry is the most sensitive to electricity consumption. So if the conversation really is about ensuring energy security, then a lot of the benefit will also be realized by the secondary sector, of which the cassava industry or cassava processing industry will be part. Impact on the Ghanaian economy. And so you realize that through nuclear electricity or through a nuclear power project, there's a whole lot of effects or positive benefit that the Ghanaian economy will actually experience. Moreover, beyond diversifying the energy mix, the promise that nuclear power really holds is the price stability that it offers. So you have the opportunity to diversify your energy mix, probably cut down on thermal energy, step up with your nuclear power electricity generation. As I explained, that the cost economics favors nuclear power in a lot of cases. That allows us to produce cheap electricity to support cassava processing and industrialization in the economy. If you also conduct some value chain analysis for the cassava value chain, you realize that it's known that there's rising demand for cassava starch at both local and international levels. So there is actually a big opportunity for Ghana to scale up. There's also, it's also seen that commodity imports for which cassava-derived products like ethanol is increasing. So we find ourselves in a situation where the country is importing a lot of ethanol, but Ghana is actually the 5th leading producer of cassava. So it's not good economics to produce high-level amount of cassava and import products like ethanol. We'd have to find ways of creating industries or engage in will have a ripple effect of improving our balance of payment and ensuring that our exchange rate is strengthened and all that, because you can't produce a lot of cassava for it to go waste and improve. Critically look at. You also realize that incomes from cassava production and post-harvest processing represent about 1/5 of overall production in the Ghanaian economy, which signals that there's enormous potential for scaling up cassava production and processing in Ghana. Farmers engaged in production of cassava, there's tremendous potential in that area. Another observation in the Ghana's cassava value chain 34% of the cassava produced in Ghana is lost along the entire value chain. It means that there are a lot of risks and problems in the entire value chain that we take advantage of the cassava sector and industrial sector. The problem is that cassava as root tuber processes, then we have to critically look at this value chain and ensure that we are improving upon this value chain. I also see that the large-scale processing of cassava is very minimal compared to all other production or economic activities along this entire value chain. It means that there is to increase production along the value chain, be it at the input side where we are producing cassava, be it at the processing side or side. There's a whole lot of opportunity to increase production, upscale industries in this area, starch industries, ethanol production and all that, and to strengthen our export base by exporting. That in itself translates into creation of more jobs along the value chain, and also if you connect the dots and if you bring the analysis home, you realize that there's a lot of potential for Ghana. And to allow this potential to be strategic in planning the cost dynamics of ensuring that we increase production for cassava, we improve processing for cassava. That will make the Ghanaian economy competitive in this area. And economic competitiveness basically means that we are trying to minimize the cost along all these areas of production in a way that when a markup is added, the final price is cheap enough to be exported or is cheap enough to be consumed in the Ghanaian economy. That's good for households, that's good for industry, it's good for help government to get some taxes from the industry. So it's a series of linkages from the energy side to the economic side to the production, on and on. So electricity is important, and that is the proposition that the Ghana Atomic Energy Commission through the Nuclear Power Institute is offering, so that Ghana builds a thriving and prosperous economy that's competitive, and to enhance our scientific and technical capacity, because nuclear power is a unique technology that comes with a lot of learning for engineers in the nuclear engineering area, civil engineering area, and all that. It's also very critical to meeting our long-term economic development objective. We are talking about one district, one factory. If we increase the analysis to, let's say, 4 industries in one district, the amount of electricity that we are going to need will be very, very enormous, and our current electricity supply may not be able to meet it. So if we are able to pursue an industrialization agenda, then we need massive electricity, and that will come from nuclear power. So if you put the dots together, you realize that there's a strong economic, macroeconomic case, overall economic case, and industrial development case for pursuing a nuclear power program for Ghana. And I think that the conversation is very timely to be discussing the interlinkages between the energy side of the conversation and the cassava value chain. And so in future, when you see a nuclear power plant in Ghana, I hope you remember the effort that the Ghana Atomic Energy Commission has made all over the years. Thank you for your audience.
Thank you very much, Mr. Festus Briukwansa, for that wonderful presentation. Before I open the floor for questions or suggestions and recommendations, I would like to know from Mr. Briukwansa, in your presentation, you mentioned a 3-phase plan for Ghana's nuclear power program. Can you tell us briefly at what stage are we in currently?
Okay, so currently we have finished all the initial research and technical documentation on the 19 infrastructure issues, submitted it to government for government to say that we are on a good path through the IAEA, you can continue. So we are having discussions with vendors. The vendors are those who sell the technology from different countries to know their technology offerings and financial considerations to be able to make an informed decision on which one we go for, which vendor we choose for the building of the plant before we can do any contracting. We also have a site that is probably called a greenfield site that is cleared and ready and can accommodate a nuclear power plant pending site approval and all that by the Nuclear Regulatory Authority. So that's where we find ourselves now.
Okay, thank you very much. That's good to hear. I now open the floor for questions, suggestions, and any recommendation. Thank you. Thank you very much.
Thank you, sir, for your presentation. And my name is Anthony Wardry from Solatel. So we are also in the renewable energy sector. My first question is, most European countries are moving from nuclear, and some of them are going to nuclear with new technologies. Can you please elaborate what type of technology are you going to use in the incoming nuclear plants? Thank you.
Okay, so currently there are several technologies on the table. Each country that is a vendor has their unique technology offering that comes with different amount of electricity production. So there is VBER 1000 from Russia. Okay, and there is HPR 1000 from China. There is NuScale from the USA. There is different countries have different technology offerings, basically, and we're actually in discussions with them. We are yet to make a decision as to which technology that we go for, because there's a lot of technical analysis that has to go into that decision making to ensure that we arrive at the technology that is, of course, favorable for the country in terms of operation, in terms of fitting into our grid, in terms of the amount of electricity that we want, and a whole lot of other metrics that we'll be looking at. So that's the kind of engagement that's going on, pending decision making.
I have another question.
Yes, please.
Please. So that's nice. The second, third question is the capacity of the incoming nuclear plant, and also what are the plans for the waste disposal? Thank you.
Okay, so as I mentioned initially, the nuclear power program involves several stakeholders, including the Energy Commission, the state, the authorized state institution that does energy planning for the country. So at the Energy Commission, analysis is being done to understand how much of thermal we need at a particular time, how much of wind we need at a particular time, how much of nuclear, if we are adding it to the mix, we need at a particular time, given the factors, industrialization, energy, demand, analysis, economic growth, growth of household sector, population, etc., etc. So that kind of technical work shows that around 2030, the demand of electricity would require that we will need an amount of nuclear electricity on board. So that kind of analysis is ongoing. The second question is the waste disposal. Okay, so I have some of my technology experts here to answer that. I'm a financial analyst, so. But I can initially say that there are several methods for managing waste. And just like I stated in the 19 infrastructure issues, it's one that is considered in our technical documentation. Sometimes a lot of people say that we have waste management issues in Ghana. To me, nuclear power waste is not the same as what may be termed boiler in Ghana. This is a very serious area that is highly regulated. So if the utility or the owner operator of the plant has to ensure that there is adequate documentation to show how it is going to be managed. One method I know is entombment. There has to be a special, secluded area where you can bury the waste and ensure that it doesn't affect the community. But all these needs to be approved by the Nuclear Regulatory Authority before it is done. So the assurance I want to say is that it's a highly regulated waste management process, and it can't be done anyhow. And it's even done under guidance of the International Atomic Energy Agency to know that you're on the right path. But I think my boss will add more.
Right. So invariably he has answered the question, but there are a lot of ways of managing the waste. Those I know from Korea and other places who are intensively using nuclear power. They don't even have a waste facility. They are now building it. But what they have is temporary storage, which can store the waste for many years before then. There are some for newcomer countries, there is the idea of sending the waste back for reprocessing. In fact, the waste can be reprocessed into other fuels that can be used in other reactor facilities. So that option too is there. So like I said, all these are processes we are going through to come up with the best option for Ghana. So.
Thank you. Thank you very much. Then my last one. Get it? No, it's okay.
Please,
okay, still on the waste processing. I'm living in Europe, but I'm here. And Belgium, for instance, they are closing some of their nuclear plants. And the storage, there's a university in Liège. They have come with a calculation that they can reduce it from maybe 300 to 400 years to 100 years. We are going to stop. And there has been a debate, the land and all the spaces that is going, those areas which is protected area for this waste storage.
Can you use the mic, please?
Please, oh, okay, sorry. The storage and the hazards involved. So that's why I'm asking that question, that this is a huge, if you're going to build a bunker to store it, it's a huge investment. So I just encourage you take the right decision for the population and also for to protect also the environment. Thank you.
Thank you very much. Yes, please go ahead.
I would like to know, there are a lot of perception about nuclear in Ghana. Yeah, a lot of perception about how safe it is. So far, what have you done to get the perception of people, and what are you doing about this perception, the myth around the use of nuclear? Thank you.
Thank you very much. That's a question that usually comes up during these conversations, and it's very important. We need to allay all fears about the safety. The situation of nuclear power is similar to road accidents and taking flights. You realize that there are plane crashes, but seldom do we hear of plane crashes. A nuclear power plant is very technical in its operation, and that makes it highly regulated to avoid any issues with safety. So there are three major, we call it the 3 S's, safety, safeguards, and security. That's also a major component of our analysis. So the work that is going on at the Nuclear Power Institute is to ensure that for the different reactor types, what are the safety precautions, what are the safeguards, what are the security measures, how do we plan our emergency zones and all that, to ensure that once we kickstart operation, we can be assured of safety. That's one. And on the side of engaging with the community to let them know how safe nuclear power is, we also have a stakeholder, localization and stakeholder management center, support center, that is doing a lot of work with engaging different communities. So the whole idea is to explain the technology. Nuclear power is really a power plant that basically uses uranium as a fuel. So you can look at it as a thermal power plant that is using gas. The difference really is the source of fuel. Uranium being used to split atoms to create heat to generate electricity. and it has enormous potential. If you abroad and a lot of countries are not experiencing doom so, it's because of these strong, powerful machinery that is creating electricity. If you go to US, about 50% of, if I'm right, yes, of the electricity output improve their economy. So we're actually late in tapping some of these technologies. I'm not saying it's 100% safe, but there are regulations in the plan to ensure that it is managed safely. And over the years, we don't hear a lot of nuclear power accident, except the Hiroshima, Fukushima, right? And the Chernobyl accident that happened in times past. It's very minimal. So we should be assured that nuclear power is safe, and we are on the right path to doing things.
Good to hear that. Thank you very much. Any more questions? Okay.
Okay. I think I heard you mention a case study in Finland where they produce at zero cost. I want to know how they did it.
Okay, so in economics, you can engage in the production of a commodity in a way that in the longer term, your average cost, or your marginal cost of producing extra electricity is minimal or near to zero. So these countries are not having the first nuclear power plants. What you do normally is that to optimize your cost, Finland is using, or they have stepped up their nuclear power source for electricity, but they are also using other sources. Every country mixes different sources. You can have a bit of solar, you can have a bit of wind, but that decision as to how much you use from each source should be a strategic decision. It shouldn't just be any decision of, okay, let's go for 30% solar, or let's go for 10% nuclear power. You have to calculate your cost, you have to calculate your output, you have to look at your strategic objective. How much do you need for industrialization? How much do you need to meet your demand? So what Finland has been able to achieve is being able to produce electricity to a certain point where their extra cost of producing electricity is very minimal or near to nothing. So it means that they can produce extra electricity at little to no cost, which means that if you're buying electricity, let's say now, let's bring it home. If you're buying electricity, let's say 100 Ghana cedis, and that affords you, I'm just giving an example, let's say 3 megawatts onto your meter to be used. You can now get 3 megawatts, or you can now get, let's say, 5 megawatts of electricity at the same 100 Ghana cedis. Because on the production side, electricity is so cheap or near to zero cost of production that we are now able to give more electricity at the same price. And that's good for every economy. It means that you can enjoy a lot of electricity that's stable all the time and not even paying much. I think it's a point that Ghana can get to if we are strategic about our energy decision making.
Okay, thank you very much, Dr. Bedu.
Thank you very much for the presentation. On your listening, I saw that you made a projection that there's going to be a 10% growth in the development as a result of introduction of nuclear power plants. On what basis are you saying 10%? Is it just a mere projection, or have a data to support it? Yes. Okay. Then you keep on saying that a place has been earmarked for the. So which place are you talking about? Exactly where is the nuclear power plant going to be established? And the people agree to, any development about where this thing is going to be sited.
Okay.
Thank you very much.
So the first question, GDP. So as I mentioned, that technical work that we did, we wanted to look at the quantitative side of our economic analysis and also the qualitative side of things. So our thinking really was, how do we quantify the effect of introduction of nuclear electricity into the Ghanaian economy? So we went for data from the Ghana Statistical Service, the data known as the social accounting matrix. So social accounting matrix is like an Excel sheet that contains the monetary transactions in the economy and the different economies. So basically, it's data about the Ghanaian economy. We model that based on the relationships with the energy sector to see how much. So, of course, if you are doing modeling, you have some assumptions. By introducing this amount of electricity, let's say 1,000 megawatts of a nuclear power plant, the monetary equivalent, we use the price, the tariff from the Energy Commission at that time, we monetize much of additional output or monetary inducement that accrues the Ghanaian economy. And that measurement is what I quote as about 10% of increase. The projection is up to 2030 when we have nuclear power. That's the timeline into the Ghanaian economy. So it's an analysis that shows a potential, a possibility. And we also further did analysis using the Integrated Business Establishment Survey. That also contains data reflect the Ghanaian economy. Employment in different sectors of the economy and incomes at different. So we model all those things, get to know how much of employment is being created, how much of labor incomes is being added and all that. That's the quantitative side. And we also did some systems analysis to see the benefit of nuclear power in the Ghanaian economy. That's what I projected with chart, and I showed that it's the industrial sector, the secondary sector, that's really sensitive to electricity. On the question of where the siting will be, I'm not in the position to declare that now. But what I can say is that a site has been found. And so further work has to be done in terms of approving of it. And the authorities who have been, just like the president announced that because of the technical work that we've done and the approval that we've had from the IAEA, Ghana can continue with its nuclear power program. I think at a certain point in time, the location or the geographical location of the site can be declared. It's in the area of engineers to do analysis and all that to finally say that we are good to go to put a plant on it. So just let's have some patience. With time, we'll see all where the site will be. But basically, I think, you know, a nuclear power plant should be close to, yes, a water source to be cooling and all that. So, I mean, at a broad level, it makes sense to say that it will be in coastal Ghana.
Thank you very much.
Please, I stand to be corrected, though, but I hear the issue with energy in Ghana is not about production, it's about distribution. And the current ECG boss is trying his best to get as much revenue as possible because there are a lot of people who are using energy, but then they are not paying for it. And that's why we have a very high cost of energy. If the problem is not production, but distribution, then why are we bringing in nuclear energy?
Okay, so what you mentioned is part of the problem. The distribution side, so in an energy market, we have the producers, the owner-operators. So in the case of nuclear power, one has been established called Nuclear Power Ghana. Just like we have VRA overseeing the hydro sources, just like we have that's the production side. We also have the downwards in the market, we have the off-taker side. So the off-taker will be the ECG and the NEDCO who are buying the electricity that is produced. So when it's produced at that level, it is distributed through the GRIDCO. And so the problems you are mentioning are at the distribution side, the metering issues. I think it's really different from issues when it comes to production, as I'm speaking about. So production of electricity then becomes how much of electricity should we produce at a particular time to meet what demand. The conversation with production is about the growth of the economy, growth of population. Right now we are in 2023, sorry. So if Ghana is growing at a certain rate in terms of population moving into the future, we need a lot more of electricity and we have to produce more. If we are going to industrialize, we are talking about cassava, we are going to create more industries, cassava industry to process cassava, we need more electricity. If we don't plan now in a way that in future, when this energy demand shoots up, and we have enough base load power to sustain the system, we'll go back to Dumso. So there's really a need to start planning now. And
then you are producing. Nuclear energy is producing power. And then there's a problem with distribution. So it's like we have enough, just like the way we do with the farmers.
we may have enough now, but it will not be enough moving forward. That's all that I'm trying to say.
Maybe I'm not making myself.
No, so let me make it simple. Current Ghana situation, let's say we are consuming 3,000 megawatts of electricity. An example. I need to get the current data anyway. 3,000 megawatts of electricity. It may be enough, and I'm not experiencing doing so because the peak demand makes it enough. The industries in Ghana, the number of industries in Ghana are consuming just what we are given. Household sector is also consuming. This is not going to stay the same. Population growth, well, people are building more houses. You know, there's population growth. So demand for electricity is going to increase. We are talking about industrialization, 1 district, 1 factory. Let's increase it to, let's say, 1 district, 2 factories. A lot more megawatts of electricity will be used moving forward. So if we are consuming 3,000 megawatts now and we think it's enough, it's not going to be enough because demand will spike moving into the future.
Because the problem now is not about production, but distribution. The problem now is not about production, it's about distribution. I understand that we are looking at industrialization, so we are producing more electricity. Now produce more, and then when it gets to the distribution side, we don't even get what we need. So
what do you mean by we don't get what we need?
You see the way farmers produce a lot of goods, but then it doesn't get to Accra. So the little that gets to Accra are very expensive. But when you go to the farm gate, it's very cheap. So the problem is with the middlemen between the farmers and the consumers. So how do you solve that problem so that we are producing more electricity, it's cheap, but then the consumer is getting what they need so that that cheap that you are producing translates to the consumer?
So one of the major issues, the infrastructure issue, is about the grid studies. The grid will be studied, the transmission line, you know, all these count, the losses you are talking about comes in terms of the transportation, distribution of the electricity. Okay, so it is also a major area that is being studied together with GridCo. Okay, and we often hear that we have a lot of power, installed power, but we still experience doomsday. And also, the industries, they produce some products in Ghana, and then we, the consumers, we realize the product is more expensive than what is imported. Okay, and usually the AGI associate that to the high cost of electricity. You see, so this is where the nuclear comes in, producing cheaper electricity. So our industries can also produce products that will be less expensive, that will be very competitive with those coming from China as well. So that's how the point is.
Yes, I think one thing, a study was conducted, and Ghana has some few issues with our transmission system and all. So GridCo is studying it. And before, like you said, one of the major infrastructure issues is grid. And so we are doing grid assessment and all. It's a lot of money to do those things, but the government is willing to support. So maybe we hold on, it will come.
Okay, Cassava, golden route for economic transformation. Linking to, that means energy demand. So Cassava is not in isolation. For Cassava being a golden route for economic transformation, to have an impact on the economy, means that we got to create linkages, like a multiplier effect within our system. So from cassava farms, cassava exchange points, there will be movement of goods and services. So a few years ago, the government was talking of railways. This requires energy. For the bullet, wondering how, I've been roaming in Europe for a while, I was wondering how we're going to get this energy to sustain it. Now, we also see that Ghana can only do manufacturing car points. Can never do with our present state of manufacturing. I mean, the gene block stuff. We can't do it. So I want to know whether, I mean, the MPI, that is nuclear power industries, in your studies, in your whether that into energy that you have projected, you said 10%.
So the 10% is impact on the Ghanaian economy. But I think what you mean is, you mentioned what electric cars, yeah? Yes. Yeah, so all these developments add up to energy demand in future. Because if you are switching to electric cars, then we are going to need more electricity. And it should be in supply, you know, and it should be at a cheap rate that we can afford. So all these feed into energy demand analysis. There are models that allow us to say there's MAED that allows us to project demand, there's MESIC that allows us to project supply and synchronize the two to make inference as to how much we need at a particular time, bringing on different things. If we are increasing industry, household sector is increasing at this point, we want to industrialize, maybe create more factories. We are able to hold all these assumptions and conclude as to how much we need. And so all these are...
So you considered the train system, I mean, the car manufacturing industries, and then are you promising small scale holders who are here with us and then online that their energy, the cost of energy is going to be decreased by 60%?
No, so if you look at my presentation, I mentioned that it holds the promise. Holds the promise means that a lot of countries have benefited from cheaper electricity from nuclear power. And so if we're able to strategically plan and optimize our costs across all those levels, cheaper electricity in Ghana moving forward. Because Temal, for instance, an expert said that if Black Stars and Super Eagles play football and Black Stars cost Super Eagles, and gas supply reduces from Nigeria, it means that we'll not get electricity. But we should be able to forge an energy system where it is sufficient, it is stable, it is reliable to support our economy moving forward. So let's see what the future holds. We have to work hard and see how things go.
Sorry, I missed the initial part of your presentation. I just want to know, what is the cost of production, as compared to hydro? As compared to hydro, nuclear power production, what is the cost difference? Is it about the same, or is nuclear cheaper? And how long does it take to establish a nuclear plant?
Okay, I'll start from the second question. Depending on the technology that you are building, usually large reactors take about 6 to 7 years to construct. That's why we started long ago in doing our technical work. So assuming we are starting in 2024, for instance, then we can add 7 years to say that around 2030 to 2031, we could have nuclear electricity on our grid. That's when everything moves business as usual, or in a normal mode, or we go according to project timeline. So 7 years for construction. And it can operate for, let's say, for a large reactor, you can operate for, let's say, 40 to 60 years before you decommission. There are also small modular reactors that can be built within 3 years. Yes. Yes, 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 yes. So it's actually technology. If it's a small modular reactor, we can do 3 years. If it's a large, we can do 7 years. The other question Yes. When you mention cost, it's a big word. And in terms of economics, so if you are talking about capital cost or investment costs, if that's what you mean, nuclear more expensive dam, but it's logical because of the nature of the technology. But operational maintenance cost, nuclear power is competitive because uranium is in abundant supply and relatively cheap a fuel source. So it depends on which kind of cost they're talking about. But normally to compare sources of electricity, then you would use the levelized unit of electricity cost, where you find the average of the various costs that's discounted with the amount of output of that electricity source. So given that nuclear power, especially for large reactors, gives a lot of 1,000 megawatts, 1,200 megawatts, usually the levelized cost of electricity is very competitive compared to other sources. That's the advantage that nuclear.
Thank you very much. You want a follow-up question?
We learned that when you use hydrocarbons, the cost is very, very expensive. Hydro is cheaper. I wanted to have an idea. Let's say if hydro, 1 megawatt is say 100 cedis. For the nuclear source, what would it be? Would it be 120, 110, and maybe from the hydrocarbons, 200 or something? So we have an idea why it's necessary to get it. And if it's that cheap, why are we still sitting here? Why should we not start implementing it so that people can enjoy cheap electricity?
The difficulty about giving cost figures when it comes to energy sources is that it's really context specific. So a lot of things have to come to play. Which kind of technology are you talking about for nuclear power? How much of electricity is that source producing? So on the whole, it's in cost experience, it's seen that nuclear is quite competitive, but I'm careful not to quote figures because the figure that I may give to you, I don't know if you're on the same page. So basically, nuclear offers a competitive cost, but it depends on the kind of technology and the output that it gives, so on and so forth. But the bit about taking a bit of time to construct a nuclear power plant is because, just like I mentioned, you have to go through a process where you're addressing all the 19 infrastructure issues. It takes a bit of technical consideration to put up a plant. You have to make sure that your legislative framework is in place. You have to make sure that your safety measures are in place. You have to make sure that your financing dynamics are in place and you're able to do the contracting. A whole lot of issues. So it's not just like any other plant where maybe it's not heavily regulated and you can go ahead and construct. Before you even go ahead to start constructing on the site, you have to get a site permit approval. The engineers have to do seismicity tests to be sure that that place is safe from earthquakes. It takes a lot of consideration. So that makes it time consuming. And so we are working hard and hoping that as we began in earnest around 2015, hopefully moving forward, we are in phase 2 now, hopefully moving forward by 2030, we would have nuclear power or nuclear electricity on our grid. That's how things look for Ghana now.
Thank you very much. Do you have a question?
Oh, just a little contribution to know that nuclear, man said, requires a lot of things. It is not like building a buoy dam. You know, when they were building buoy dam, the moment they have the water there, they build the things and then fast. Where to dump your waste, where to, you know, even the nuclear park where you need a place of a water body to cool them for you and all those stuff. So it is a cumbersome thing. It's not like you go and sit down one day and say, no, I want to build a nuclear power. And that thing is also like you need a committed government. I think even the 2030, we are still praying that by the grace of God, when we get there, we'll be able to at least say that now there we have gotten there and we are going to build it up finally. But it is not something easy.
Yeah, I wouldn't call it cumbersome. Sorry if I wouldn't call it cumbersome, but I think the word I want to use is technical, and that's very knowledge intensive, and that's why we conduct a lot of studies vetted by the IAEA from Austria. They send experts down to come and look at what Ghana is doing, check all these issues, whether we are on the right path, make sure we are crossing our T's and dotting our I's so that we are not making any mistake along the way. So that once we present to government and government says that, okay, we're on the right track, then we move forward. So just like he said, it also requires government commitment so that you reduce that political risk and so that the management is smooth. So it's not cumbersome. There's a lot of knowledge to guide it. And there's a lot of expertise. It will marvel you that if you go to other countries, you'll find Ghanaian experts probably working in nuclear power plant. But because we don't have a plant in the country, they are not here. So if Kwame Nkrumah started it and we could have done it long ago, then I think that we are actually late. And we have to really work and move forward.
Thank you very much. Dr. Nete.
Okay, thank you. You're right. I have a lot of friends in America and elsewhere working within the nuclear power industry. So you are right. May I know that our nuclear power agenda, how will it impact on our environmental issues, ecological issues? You need water to cool it. So how will this water interact with aquaculture and other things? Thank you.
Thank you for your question. So these studies are technology specific. When you take the Hualong 1, that is the Chinese reactor, it has a distance with which it releases the waste, the hot water. Let me use it this way: hot water from the reactor into maybe the source of the cooling, and it is done in such a way that it won't affect the other living organisms, the fish and all those things in the river or the sea. So it's technology specific, and that study is carried out for each site that the plant will be built.
So what about other environmental factors, like the air quality, the soil microorganisms, and all that?
So we have what we call level 2 PSA that deals with early releases and all those things, how it affects the environment and all. Normally, before you go for a reactor, you want to check all those things. They have their stated value for those things, but you also need to conduct your own assessment to check to see whether it's within the acceptable limits, internationally acceptable limits. So that's what we will need to do when we settle on the vendor and what reactor we are going to do. Those are some of the analysis we have to do to see whether it's within the acceptance criteria. Now, when it comes to how it affects the soil and other things, again, there is another analysis. That's the PSA level 3, how radioactive substances affect those things. Those ones too are conducted before you even bring in the reactor. So those are assessments that need to be done before then you can go for the reactor.
So that's it. My manager has said it. We have what we call the plant parameter envelope. That is the impact of the plant on the site and then the site on the plant. So the technology holder designs his plant. Okay, these are the parameters. The plume of the plant, maybe snow load, they study all that. But now this plant will be built in Ghana on a site somewhere along the coast. We don't have snow. So whether this meteorological impact do we have that can affect this plant? Those studies are being carried out as we speak, and then as my my friend said earlier, earthquake is also being studied because there are machines right now. There are machines on each of the sites recording all the natural phenomenon, wind speed, earthquake, flooding, and all. There are a lot of studies that are being studied, so it's not a problem.
Okay, so from what I do, we develop technologies and then we transfer to the end user. So you can do all that you want to do and then paint it any color. If you go to the end user and then it's not ready to accept it, it will never be updated. So I want to know what GAEC or you are doing in a way of preparing the Ghanaian population to accept, because we have a myth, even irradiated food, some people don't want to touch it, because, so let alone the whole nuclear plant. What work are you doing to demystify the minds of people about the thoughts and stories that you've heard about nuclear energy plants?
Okay, I'll say a bit on that. So in the Nuclear Power Institute, one of our centers, as I mentioned, Localization and Stakeholder Support Center. We also have the Public Relations and Information Center that is doing a lot of PR work. They've been on a lot of media stations, Joy News, a whole lot, like radio, trying to demystify all these myths around nuclear and, prepare the minds of Ghanaians for this kind of energy source so that the communities can also embrace it as a potential source of energy that can benefit the Ghanaian society. So a lot is being done. And I can also mention that there is an MOU that was signed with Ghana Journalists Association with the Nuclear Power Ghana. Nuclear Power Ghana is the owner-operator, just like we have VRA, We Power Authority. There is a utility that has been established under the government to manage a nuclear power plant in Ghana. It's called MPG, Nuclear Power Ghana. So that engagement with the Ghana Journalists Association is basically to continue interaction with them, engage them, help them to understand the nature of the technology so that they will also be part of the conveying the message about nuclear to their listeners. So a lot is being done, and moving forward, a lot more will be done.
And also, MPG, the Nuclear Power Ghana, also is working in collaboration of Legon, where they are carrying out public perception survey on nuclear power. That's countrywide.
So, like he said, there's a localization and stakeholder support center is engaging the civil society, so that when we're able to explain to the civil society organizations, then they will take it to the grassroots people. So they will explain it to them how safe it is and all. So we are engaging all manner of people, engaging all manner of assessments to make sure that.
In my opinion, I think all these things should have been done before we say we are going nuclear. Or is it because Kwame Nkrumah started it before we were born?
Okay, so if you remember in the presentation, I mentioned that there are 3 phases. All these issues are handled at all phases. So it's an ongoing process. You do some at phase 1, phase 2, and all. So stakeholder engagement is part of it. It's one issue. You handle all those issues, and there's a lot of strategic and technical guidance about how you do it, especially for nuclear. That's provided by the IAEA, and Ghana has been a beneficiary of such knowledge, and that's what we are implementing in our case.
So if Ghanaians, in the rural areas, the population is more than that in the urban areas, if I'm right. So if at the end of the day you take a census and then the Ghanaians says they are not, they don't want nuclear.
I think that technical work has been done, right? Yes.
No, we want energy. Ghanaians can say, okay, we don't want the nuclear, we want maybe solar, and how will you convince us?
That technical work has been done with ICE, right? Yes.
So technical works have been done. In fact, your concerns are valid because in France, a friend told me that if they had not gotten the common people to accept it, it was not going to materialize. So what you are saying is valid, but works are underway to make sure that we demystify all those things.
It's very true. Nuclear power is sometimes beyond nuclear science, actually political science, trying to get people to allay all fears. Because once people hear nuclear, even people I work at the Ghana Atomic Energy Commission, it's a bombs, no? I don't know. We don't manufacture bombs, do we? So people have a lot of perceptions about the word nuclear. All that they hear is nuclear bomb, nuclear bomb. No, you can use or split atoms for peaceful purposes to benefit the economy, and that's what we are about.
Thank you very much. Any more questions? Okay. Nuclear energy is clean energy. Nuclear energy is reliable and sustainable. Nuclear energy is cheap energy. At this point, I would like to release our speaker, Mr. Festus Brew Kwanzaa. Thank you very much.
Okay, thank you, our moderator, Dr. Andrew Sarkodie Apia. He didn't allow me to ask my last question. Should I ask? All right, so I'm in touch with a lot of small-scale enterprises. So with all that you have said, what should be their take-home in terms of energy?
Okay, all I'm trying to tell them is that we are working towards energy security for Ghana. We've experienced a period we call doomsday period, where these small-scale enterprises, someone selling pork meat, chicken, they will say that even recently in the news, they will say that their meat is spoiling because there's no power. I want to say that Ghana can get to an electricity system regime where power can be very stable, can be very cheap, in a way that we'll have electricity almost all the time to support their small-scale activities. So what we need to do now is to get all stakeholders on board to ensure that this nuclear power program comes into fruition for the betterment of the Ghanaian society and the Ghanaian economy. Thank you.
Thank you. A million thanks to you. A round of applause. All too soon, we have come to the end of our panel discussion and then our presentations for today. The exhibition is still ongoing till the close of the day today. Tomorrow, we continue the Cassava Week celebration with a Farmers Forum engagement, at Anmaobi. We are moving camps from here to Anoma-Wobi in the central region, near Bojuasi. Okay, good. So over there, we are going to look at the innovative development in cassava cultivation, an avenue for enhancing the livelihood of the Ghanaian cassava farmer. We also look at good agronomic practices in cassava cultivation. And then also we look at cassava diseases, prevention and control in Ghana. Then we have invited Agra to come and talk on ensuring smallholder cassava farmers, ensuring that smallholder cassava farmers benefit from innovation-driven productivity and gain access to friendly markets and finance to improve their livelihood. Then the last will be value addition to cassava. Which part of the chain do you belong? Tomorrow is going to be talk pack, a lot of activities at Anmaobi. We have a limited resources, so we've tried our best to arrange for a bus that will leave here, I think, latest by 7 a.m. It will leave GAEC, the police station there, to Anamaobi. The list is going around on the platforms and other places. Can they put up your name and then join the bus to the place? If you have your own means of coming there, it's also accepted. Please join us either in person or online to make our Cassava celebration a grand one. Thank you very much. I hand over to the moderator.
Thank you very much, Coordinator. I think we've come to the end of session 2. And I would like to thank our speakers and other panel members for the wonderful job that they have done, for the insights that they have given us when it comes to nuclear power. We do appreciate that. And we say that thank you very much. We look forward to seeing you in the next Cassava Week celebration. Thank you very much.
Ejanumbo,